For 4 decades, the M1 Abrams has been the most dominant main battle tank on Earth. Then, on September 6, 2023, the U.S. Army signed a memo that conceded something extraordinary. At 73 tons and climbing, the Abrams design had finally reached its limit. The M1E3 they just unveiled is not another upgrade. It is a BET that the tank the Army has relied on for a generation cannot fight the wars ahead. On September 6, 2023, the United States Army issued a formal memorandum that drew a hard line under decades of incremental Abrams upgrades. The order, signed by Army leadership and confirmed in the Congressional Research Service record, directed the immediate termination of the M1A2 SEPV4 program. The memo said that the current Abrams platform had reached a weight and integration ceiling that precluded further capability growth. That ceiling, 73 tons, was no longer just a number. It had become a barrier to deployment, logistics, and modernization. Major General Glenn Dean, Program Executive Officer for Ground Combat Systems, put the rationale in plain terms. He said the Army needed a new generation vehicle under 60 tons. The Abrams tank could no longer grow its capabilities without adding weight, and the Army needed to reduce its logistical footprint. His statement captured the institutional bray with the past. The era of stacking new technology onto an aging hull was over. Instead, the Army would pursue a clean sheet design, one that prioritized weight reduction, modular upgrades, and survivability from the very start. The September 2023 memo did more than shift program funding. It set a new mandate for Army engineers: deliver a tank that could operate within the real-world limits of airlift, rail transport, and NATO bridge classes. The under 60-ton target was not an aspiration. It was a requirement. This decision triggered an engineering crisis and a compressed development timeline, forcing the Army to rethink every aspect of the Abrams formula. For the first time in decades, the Army was betting that the old path of perpetual upgrades had reached its end. 73 tons is not just an engineering statistic, it's a barrier that shapes every move the U.S. Army makes with its armored force. At that weight, the current Abrams strains the limits of America's own transport and infrastructure. A C-17 Globemaster III, with a maximum payload near 77 tons, can barely carry a single, fully loaded Abrams, leaving almost no margin for ammunition, crew gear, or support equipment. The alternative, the C-5 Galaxy, can handle the mass, but not the turret height, forcing crews to partially dismantle the tank before flight, an operation that burns time and resources in any rapid deployment. On the ground, the story is similar. U.S. Army transport manuals set a 100-ton limit for standard rail flat cars, but the Abrams, with its full combat load, often approaches or exceeds 85 tons. This leaves little room for the safety margins required by regulations, and sometimes forces the Army to use rare heavy-load rail cars, complicating logistics across the Atlantic or inside Europe. Highway movement is no easier. The Army's heavy equipment transporters max out at around 70 tons, and the Abrams already exceeds the NATO Bridge Class 70 standard, restricting its routes and requiring engineering units to reinforce or bypass many bridges. This weight penalty isn't just a headache for logisticians. It directly limits how quickly tanks can move to the fight, how flexibly they can maneuver across rivers and urban terrain, and how much supporting infrastructure must be risked or rebuilt under fire. The Army's new sub-60-ton mandate is a direct response to these real-world constraints. Cutting more than 10 tons from the Abrams isn't about chasing a lighter number on paper. It's about restoring operational reach, speeding up deployment, and reducing the exposure of convoys and engineering teams on a battlefield now defined by drones, long-range fires, and rapid logistics cycles. On today's battlefields, Tanks face threats that did not exist when the original Abrams rolled out. Loitering munitions, small drones that circle overhead for hours, can strike with little warning, targeting the weakest points on a tank's roof. In Ukraine, footage of turret-top explosions has become a grim signature of modern armored warfare. Russian and Ukrainian forces have both suffered losses from drone-delivered grenades and guided munitions. The numbers are telling. Open-source analysts documented hundreds of armored vehicles destroyed by top-attack drones in a single year, a spike that caught the attention of United States Army planners. Precision-guided artillery and anti-tank missiles now reach farther and hit harder, often homing in from above rather than the front. These weapons do not just threaten tanks at the front line, they can strike deep behind it, hunting convoys and reserves. For operational commanders, the old calculus of armor thickness and frontal protection no longer guarantees survival. Instead, the question has become how to defend against threats that can appear anywhere, at any time, and from any angle. The Army's response is not just about thicker armor. It is about rethinking how protection is built into the tank from the ground up, and how digital systems might help crews see and react faster than ever before. Protection on the M1E3 starts not with extra layers added after the fact, but with a new foundation. The tank's armor is built from advanced composites, nanostructured ceramics, and ultra-high molecular weight polyethylene laminates, delivering the same level of protection as legacy steel, but at a fraction of the weight. Modular side panels, each weighing about 3 tons less than their predecessors, can be swapped or upgraded without redesigning the hull. This approach frees the design from the weight spiral that plagued earlier Abrams variants. The active protection system is no longer an afterthought. It is integrated into the baseline, using radar and countermeasures to intercept incoming threats before they ever hit the armor. For the first time, every M1E3 will roll off the line with APS as standard equipment, not a field retrofit. The crew is housed entirely within the hull, a departure from the traditional manned turret. This arrangement, made possible by the autoloader, reduces the risk from top-attack drones and guided munitions that have proven so deadly in recent conflicts. Defense analysts caution that any weight cut brings trade-offs. Yet, by embedding survivability from the start, the M1E3 avoids the cycle of bolted-on armor and ballooning mass. The result is a tank that matches the threat environment of today without exceeding the logistical limits that forced the Army's hand. The Army's push for a lighter, more adaptable tank extends beyond steel and armor. At the heart of the M1E3 is a digital backbone built on modular open systems architecture, MOSA, a requirement set by the Department of Defense since 2021. This approach breaks from the old model, where hardware dictated upgrade pace, and every new sensor or radio meant costly redesigns. Instead, MOSA turns the tank into a software-centric platform. Engineers can now add or swap out sensors, defensive suites, or electronic warfare packages through standardized interfaces, often with software updates rather than physical overhauls. The Army describes this as a future-proofing strategy, a tank that can keep pace with emerging threats and technologies, not just for the next few years, but over decades. Sensor fusion, where feeds from drones, satellites, and ground units converge in real time, becomes possible through this open digital network. MOSA is more than a technical detail. It is the Army's answer to rapid change, promising upgrades in months instead of years, and making the M1E3 a living platform, not a static machine. Congressional budget records for fiscal year 2025 show a $774 million line item dedicated to Abrams modernization, a sum that signals the Army's commitment has passed the point of no return. This funding is not just a placeholder. It underwrites the rapid transition from planning to hardware, with the first M1E3 engineering prototype scheduled for delivery on December 12, 2025. That date, locked into the PEO Ground Combat Systems contract, represents a concrete milestone. From this moment, the Army is financially and operationally invested in a new tank architecture, not just incremental upgrades. The accelerated timeline compresses what would normally be a 5 to 7 year cycle into less than 3, driven by the urgency to address battlefield vulnerabilities exposed by recent conflicts. The $774 million commitment anchors the program in real dollars, ensuring that the prototype's arrival is not theoretical. It is a tangible step toward field testing and eventually production. While the Army accelerates its push toward the M1E3, the legacy Abrams fleet continues to command a massive share of resources. Congressional appropriations for fiscal year 2025 earmark $774 million for Abrams modernization, but this figure sits alongside an annual sustainment bill of roughly $3 billion to keep the SCP version 3 fleet operational through 2030. Government Accountability Office audits highlight that depot overhauls, spare parts, and readiness upgrades for existing tanks remain non-negotiable expenses, even as funding for the new tank ramps up. The result is a fiscal tug of war. Every dollar spent on developing and testing the M1E3 competes with the costs of keeping more than 3,000 legacy Abrams ready for deployment. Congressional oversight committees have pressed Army leaders to justify this dual-track approach, warning that the pressure on sustainment lines risks slowing both modernization and current force readiness. The Army's budget tables reveal a force caught between the demands of today's wars and the promise of tomorrow's technology. Today, the Army's gamble on the M1E3 is a public admission. Incremental upgrades can no longer outrun modern threats. As drones and digital warfare redefine the battlefield, the real test is not building a new tank. It is proving that military doctrine can adapt before the next war arrives.